Every modern identity system promises zero trust, but few actually deliver it. In this course, you'll see how PKI, AD CS, ADFS, and Microsoft 365 truly fit together, so you can design a secure, scalable, and auditable digital trust architecture. Identity and access are now your real security perimeter. PKI and Active Directory certificate services form the foundation, binding user and device identities to strong cryptographic keys. When that trust fabric is healthy, VPN, Wi-Fi, and applications stay protected. But legacy ADFS, weak templates, and unprotected certificate servers become high-value targets for attackers. The mandate today is clear: harden PKI, modernize federation toward Microsoft 365 and Entra ID, and layer continuous identity threat detection on top. Before we connect AD CS, ADFS, and Microsoft 365, we need the core engine: digital certificates. A certificate binds an identity to a public key. The private key stays secret and is used to sign or decrypt. The public key is distributed and used to verify signatures or encrypt to that identity. A certificate authority vouches for that binding by digitally signing the certificate, while a registration authority verifies the requester before the CA issues anything. Together, these components enforce the CIA triad: confidentiality through encryption, integrity via hashing, and authenticity with digital signatures. This is the trust anchor every modern identity solution builds on. Now let's look at AD certificate services as the trust engine for your Windows domain. Because it's integrated with Active Directory, it understands your users, computers, and groups, and can issue certificates that align with that identity data. As a consultant, this is powerful. You define certificate templates once, then use group policy to auto-enroll the right certificates to the right devices and users. No spreadsheets and no manual requests. Endpoints silently receive and renew certificates in the background, so VPN, Wi-Fi, web servers, and even code signing can rely on strong, consistent PKI without user effort. That combination of deep integration, policy-driven automation, and silent provisioning makes ADCS the anchor of internal trust. ADFS sits on top of that and acts as a federation bridge between your on-premises Active Directory and cloud services like Microsoft 365 or external SaaS apps. It satisfies the hybrid requirement. Users still authenticate with AD, but their identities must securely cross organizational and cloud boundaries without creating separate accounts everywhere. To achieve this, ADFS uses claims-based authentication. After AD validates the user, ADFS issues a signed token containing claims such as UPN, email, and group membership. It also performs protocol translation, converting that internal identity into SAML, WS-Fed, or OAuth tokens that cloud applications understand, and then enforcing access based on those claims. Here's how these pieces operate together as a secure ecosystem. Active Directory Certificate Services issues the critical certificates your ADFS farm depends on. SSL for secure channels, plus token signing and token decrypting certificates. ADFS uses the private key of the token signing certificate to cryptographically sign each authentication token it creates. That signature is the guarantee that the token really came from your organization. When a user accesses Microsoft 365, the cloud uses the matching public key to validate the token's signature. If it checks out, the claims are trusted and access is granted. Taken together, PKI, ADFS, and Microsoft 365 form a single, trust-anchored pipeline for identity. Introducing AD CS and ADFS also expands your identity attack surface in three important ways. First, AD CS misconfigurations. If certificate templates are too permissive, an attacker who compromises any domain account might enroll a certificate that lets them authenticate as a domain admin, then maintain that access with long-lived forged certificates. Second, sync agent hooking. Tools like EntraConnect often run with powerful writes and store cached credentials. Malware can hook those processes or scrape memory to steal the sync account and pivot into both on-prem and cloud. Third, token theft and golden SAML. If the ADFS token signing key is stolen, an attacker can mint valid SAML tokens for any user, bypassing MFA and conditional access as if they were your identity provider. When you design PKI for AD CS or ADFS, the single biggest decision is where your private keys live. Software-based key storage keeps keys on a regular server. It's convenient and cheap, but if that host is compromised, Malware or an insider can extract your CA or token signing keys from memory or disk, often a major compliance red flag. A hardware security module is purpose-built to solve this. Keys are generated and stay inside tamper-resistant hardware, often FIPS validated. If someone tries to open or modify it, the device wipes the secrets. For internet-facing federation or high-assurance keys, HSMs move from nice to have to non-negotiable. Next, compare legacy ADFS with Microsoft Entra ID. You're really comparing on-prem plumbing to a cloud security service. With ADFS, you manage everything: load balancers, WAP servers, certificates, OS patching. Every upgrade and every outage is your responsibility. Entra ID offloads that to Microsoft and authenticates using password hash sync or pass-through authentication, so your team focuses on policy, not servers. Access control also modernizes. Instead of static claims rules and separate MFA plugins, you use built-in conditional access that evaluates user, device, and risk in real time. And resiliency improves because if your data center link drops, cloud sign-ins can still succeed. With that in mind, here's the end state we're aiming for. Microsoft Entra ID becomes the primary identity provider for Microsoft 365, using seamless SSO and password hash sync instead of ADFS. That allows you to remove the federation farm, web application proxies, and all the complexity they bring. On-premises Active Directory still matters, but now it focuses on internal identities and synchronizing to Entra through Entra Connect. Add certificate services remains in place, but its scope is tightened to internal device certificates, Wi-Fi and VPN authentication, and any remaining on-prem apps. To harden PKI, the root and issuing CA private keys are stored in a FIPS 402 Level 3 hardware security module, giving you strong, auditable protection for your trust anchors. To harden ADCS itself, start by anchoring your keys in hardware. Deploy physical or cloud HSMs and integrate them with Windows using PKCS number 11 or CNG, so cryptographic operations never rely on software-only keys. Next, install the HSM vendor's key storage provider on the ADCS servers. That redirects key generation and signing to the HSM. Then run a formal key ceremony. Either migrate existing CA keys into the HSM, or generate new root and issuing CA keys directly on it. Those keys must never appear in plain text on the OS. Finally, take your root CA offline and rely on subordinate issuing CAs for day-to-day operations. Migrating from ADFS to Entra ID is essentially a trust and authentication cleanup exercise. You begin by discovering what actually depends on ADFS today. List every relying party, which protocol it uses, and which claims it needs. That tells you what must be reproduced in Entra ID. Then configure Entra ID Connect and decide password hash sync for simplicity, or pass-through authentication if regulatory or security constraints require it. Enable seamless SSO so domain-joined devices glide through. After that, pilot the change. Move a small representative set of apps and users, map the required claims, and fine-tune conditional access and MFA. Once you're confident, cut over the domain, monitor the logs closely, and only then retire your ADFS infrastructure. Cloud PKI integration is about treating your on-prem ADCS as a secure issuer and Azure Key Vault as the distribution hub for modern apps. First, register an application in Azure AD and create a dedicated service principal. Think of this as the identity your PKI platform will use when talking to Azure. Next, configure your ADCS workflow with a tracking or connector certificate so that this service principal can securely authenticate to Azure and prove it's allowed to move keys and certificates. Finally, carefully scope Key Vault access policies so that service principal gets only the certificate permissions it truly needs. Typically get, list, and import, plus create if you're allowing issuance in cloud workflows. Active defense is about turning your identity systems into sensors and tripwires, not just gates. Shift from reactive alerts to preemptive controls. In practice, that means programmatically denying risky behavior and sprinkling in deception so attackers can't tell what's real. Honeypokens are a good example. You create fake privileged accounts and fake certificates in Active Directory and ADFS. No user or app should ever touch them. So the moment a Kerberos ticket, certificate request, or login targets one of these, you treat it as a confirmed incident and automate containment. Then add stateful token validation across Entra ID, ADFS, and Microsoft 365. Track token lineage, certificate thumbprints, and device claims so forged or replayed tokens are revoked instantly, cutting off lateral movement. All of this rolls up into a focused 90-day execution plan. In the first month, you're understanding and designing. Review ADCS templates for ESC risks, inventory every ADFS integrated app, map their claims, and define your target architecture, including HSM strategy. In the second month, you harden and prepare for hybrid. Deploy FIPS-compliant HSMs, lock down ADCS, configure Entra Connect and seamless SSO, and scatter honeypot identities to detect abuse early. In the final month, you move production. Start with pilot apps in Entra ID, tune conditional access, then flip your tenant to managed authentication and retire ADFS, validating each step with detailed traffic and security logs.